Welcome to this month's Opsgility webinar, where we'll be discussing the topic of connecting virtual networks through a relatively new capability called virtual network peering. My name is Steve Ross, and I'll be your host today. Just a quick note on our company as we get started with our webinar. Opsgility focuses entirely on helping organizations enable the Microsoft Cloud, including Azure, Office 365, and Dynamics CRM. We are a Microsoft Gold Cloud Platform partner, and we offer several ways for you to consume training content, including self-paced online training and instructor-led training. Also, we just released the Opsgility Cloud Sandbox, which is a subscription management system that allows you to provision Azure resources for dev, test, or training purposes, and apply strong controls and quotas that prevent overspending. As I mentioned today, we'll be talking about virtual network peering in this webinar. The specific topics that we're going to cover today are a brief overview of virtual networks. Virtual networks are the core of networking concepts in Azure. From there, we'll discuss ways to connect virtual networks, focusing on VNet peering, as I mentioned. And finally, we'll finish with a discussion on the different use cases that VNet peering enables. My name is Steve Ross, and I'm a cloud solution architect with Opsgility. Prior to Opsgility, I was with Microsoft for about 7 years, and I've been in the IT industry in many different roles for over 20 years. So as we move into our topic, let's lay a foundation by quickly covering what a virtual network is. The most fundamental construct with Azure networking is the virtual network. Any IaaS or infrastructure as a service deployment will require a virtual network, since this is the basis which allows network communication between resources in Azure and between an on-premise network in Azure. In a virtual network, I define the address space and partition that address space into as many subnets as are required by my workload. There is front-end access into the virtual network, exposing capabilities like public IP addresses, load balancing, and DNS services. There's also back-end connectivity, enabling connections to other virtual networks or on-premise networks through VPNs or via ExpressRoute. A key point to remember about virtual networks is they are isolation boundaries. Your virtual network is a completely private network with no default ingress points. So if you have more than one virtual network, then by default, traffic cannot pass between them unless you enable it. This leads naturally to the question, how can I connect my virtual networks, especially if I'm managing multiple subscriptions? It might be best to first discuss why an organization might need or want to have multiple virtual networks. It's common for larger enterprises to manage multiple subscriptions. In some cases, there is one or more subscriptions assigned to each business unit or department in the organization. This separation allows for easier segregation of costs and management responsibilities. However, a virtual network cannot span subscriptions, so it becomes necessary to connect multiple virtual networks together. We have two options today for connecting virtual networks in Azure. The first is to establish a site-to-site VPN connection between the VNets. This option works whether the VNets are in the same or different regions, Azure regions. The two things to keep in mind concerning this method, though, are cost and performance. To establish a site-to-site VPN between your VNets, you must provision VPN gateways within both virtual networks. This increases the costs and complexity of your deployments. Also, VPN gateways have a maximum bandwidth of 200 megabits per second, which is just not adequate for most organizations' requirements. It's important to understand that prior to Microsoft Ignite last year in 2016, site-to-site VPNs or linking virtual networks to an ExpressRoute circuit were the only ways to connect virtual networks. The second option is called VNet peering. This option is only applicable or available when the virtual networks are in the same Azure region. However, it does not require the use of VPN gateways. Also, there is no bandwidth limit besides those that are imposed on the virtual machines themselves. In essence, peering makes your VNets appear as a single network. However, the VNets themselves remain separate resources. This is an advantage since it allows administrators to segregate out duties for management. For example, one group could be granted rights to manage the IT VNet, let's say, while another manages the HR VNet. Traffic passed between peered VNets traverses the Azure private network, and it is not encrypted. Note that the network latency for a round trip between two virtual machines in peered virtual networks is the same as for a round trip within a local virtual network. So what are some of the benefits of virtual network peering? Well, I've already mentioned one, the fact that we don't require VNet gateways when we establish a peering relationship. So this is going to reduce cost and complexity in our subscriptions. Also, there's no bandwidth cap imposed on peered VNets. The only limits are those that are on the virtual machines themselves based on the series and size. You can see that information in the Azure documentation on virtual machines. Also, another advantage is the ability to connect classic and ARM virtual networks together. So this can be a significant benefit whenever you're doing migrations, perhaps, from Classic into Azure Resource Manager. Another benefit is reduced overhead as the traffic traversing the Azure backbone is not encrypted. And the last benefit that I'll mention is the ability to share infrastructure components so that peered VNets can use those components. Great example is a firewall that is deployed in a single virtual network, and other peered VNets will be able to use that firewall across that peering connection. So this cuts down on resources in the subscription and complexity. This last point is going to make a little bit more sense in a few more slides when I show you some of the use cases for VNet peering. So how about caveats? As with any technical solution, there are benefits and there are also caveats. So these are some things to keep in mind when planning for the use of VNet peering. So the first one is that there is no transitive relationship implied between VNets that both connect to a hub VNet. So you can see in the diagram here that A is peered with B and C is also peered with B, but this does not imply any connectivity between virtual networks A and C. Another thing to keep in mind is that VNets that will be peered cannot have address spaces that overlap. Now this is a similar requirement to what we had previously when we connected VNets with VPN gateways. Also, while peered resource manager based VNets can be in different subscriptions, each subscription must be linked with the same Azure Active Directory tenant. Now, when peering a VNet in Classic mode with one in Resource Manager mode, both of those virtual networks must reside in the same subscription. And just to make sure we're clear on the encryption side of things here, there is no option in VNet peering to enable encryption. If you must enable encryption, if your organization requires that, you're going to have to sort of default back to using VPN gateways to connect those virtual networks. Now, some organizations are going to be okay with no encryption because it is a private network that the traffic is traversing, the Azure private network. But again, if you must use encryption, use VPN gateways. Also, Azure-based name resolution. This is the way that we resolve names within a virtual network by default. That method of name resolution only works within the VNet that it is enabled for. And so if you want to enable name resolution between virtual networks, then you're going to have to supply or use your own DNS servers. And I'll show you what that looks like when I do the demo portion of this webinar. Lastly, you should be aware of the limited number of peerings per VNet. The default limit is 10, but this can be increased with a support case to a maximum of 50. Okay, let's talk about some of the use cases that VNet peering enables. The key benefit, really, of virtual network peering is reduced complexity and cost. In large enterprises, it's common for organizations to provision one or more subscriptions for different departments or business units. Each department would create a virtual network and deploy their workload in it, which in effect created many isolated network boundaries. Each virtual network would oftentimes have resources deployed that could be shared across the organization, such as Active Directory domain controllers, firewalls, or monitoring servers. But the native isolation of VNets made sharing those resources difficult. Well, VNet peering brings options for connecting these isolated VNets and provisioning shared services in a single virtual network that all of the other peered VNets can communicate with, thereby reducing the IaaS server count. And this, of course, reduces complexity and cost. In this example, now the marketing subscription in VNet, and the HR subscription in VNet will be leveraging those domain controllers, the monitoring server, and the firewalls that are deployed in the IT subscription. The example that I gave in the last slide of using a firewall in a peered virtual network from another virtual network, this is a capability called service chaining. Service chaining implies the use of what is called user-defined routing to control the flow of traffic. In this case, we are setting up a route that forces traffic from a subnet to use a network virtual appliance in a peered VNet as the next hop. So in the context of VNet peering, traffic leaving a subnet in one VNet can be directed to a virtual appliance in another virtual network. You can see in this example, traffic leaving the marketing and the HR subnets is being directed to use a firewall appliance in the IT virtual network. VNet peering also enables a VPN gateway in one VNet to be used by peered virtual networks. This is called gateway transit, and it allows traffic to flow between peered virtual networks and on-premise networks. So in this example, you can see that the on-premise network, sort of at the bottom of the image, users there will be able to communicate with and leverage and use resources in the IT subscription and in the HR subscription. And traffic's going to be able to flow between them, again, because both the IT and the HR virtual networks are using the same gateway, the one provisioned in IT, to connect to that on-premise environment. So now I'd like to demonstrate for you how to establish VNet peering and show you two examples for traffic traversing that peering connection. Now, before I do, just to show you quickly about my demo environment, you can see here that I have two subscriptions. I have the IT subscription with a single virtual network, and in that virtual network there is a DNS server and a Linux VM. And then in the HR subscription, I have a single virtual network, and I also have a load-balanced web site that's deployed on infrastructure as a service VMs, and that is balanced with an internal load balancer at the top. The traffic's balanced to the two IIS servers. Now those IIS web servers need that SQL server because this website requires the use of SQL. And then lastly, I have a Linux VM deployed in that virtual network as well. So the use cases that I'm going to show you, or the things I'll demo for you, the first thing is I'll set up peering between these two VNets. And then I'm going to show you how you establish or set custom DNS servers in your environment on the different virtual networks. This is something I won't actually do in the demo. I've already set it up, because when you make this change, you have to reboot your servers in the virtual network for them to take notice of that change. So I've already set that up, but I'll show you how to do that. The next thing I'll show you is I'll connect from that DNS server. I'll connect it to the load balanced website in the HR virtual network using its name. And I'll first resolve that name just to show you that it is a private address. And any connections, of course, are going to have to traverse the peering connection if it is a private address. So I'll show you that. Lastly, I'm going to ping from one Ubuntu server to another across this peering connection using the private address. And the main thing I want to show you here is the low latency of this connection. Okay, so with that, I'm going to bring up my Azure subscription here. And again, I want to start by showing you that I have two subscriptions provisioned. So here in the Azure portal, you can see the HR subscription and the IT subscription. And then also I have two virtual networks provisioned. Here is the HR VNet. Notice it is connected here, or a part of the HR subscription, and the IT VNet, a part of the IT subscription. So let's click on one of these virtual networks, and I want to start by showing you where you would set custom DNS servers. So in the menu options here of the virtual network, I can click on DNS servers, and notice that there is a default option called Azure Provided DNS. Now again, this option only allows name resolution within the virtual network. So if we want to resolve names across virtual networks, or even maybe into our on-premise environment as well, we'll have to use our own DNS servers. So I've set this to custom, and I've entered in the IP address of my DNS server. And I made the exact same change in the IT virtual network, as you can see. Okay, so before I do anything else, before I set up the peering relationship, I just want to show you that connectivity between these virtual networks does not work currently. There's no way that that traffic can traverse between these two isolated networks. I'll just briefly show you that peering is not set up, as you can see here. Okay, so what I'll do is I'm going to SSH into one of my Linux VMs. And if you remember from the diagram here, I'm going to SSH into this HR virtual machine. Okay, so I've logged into the VM. You can see here that it is an Ubuntu server. And what I'm going to do is now ping the private IP address of the IT Linux server. Okay, so you can see that pings are being attempted. And when I Control-C, you can see that 6 packets were transmitted, none were received, so we're at 100% packet loss currently. So no connectivity right now between these two VMs or these networks, because we've not set up the peering relationship yet. Okay, so I'm going to start now with setting up the peering relationship here, and I'll start with the HR VNet. So I've clicked on peerings, and I'm going to add a new peering. Now, one thing you're going to see me do is I will add a peering relationship on both sides, really, or within both of the virtual networks. I have to do that in order to connectivity to flow in both directions. So I need to give it a name. Now, again, we're starting from HR, so I'll just call this HR to IT. Now you see here that I can select either Resource Manager or Classic. So if I wanted to connect a Classic VNet to a Resource Manager virtual network, I can do that. Now in this case, both of my virtual networks are Resource Manager mode, so I'll leave that set. Notice here I can choose the subscription. So I'm focused on the HR VNet, and I want to link to a virtual network in a different subscription. So I'll click this to drop down and choose the IT subscription. And then I'll click choose a virtual network, and we want to peer with the IT VNet. Now just briefly, let me show you these options and what they're for. The first option under configuration is going to either enable or disable network traffic between this peering connection. So by default this is enabled, and if I set this to disabled, in effect it would be as though I had no peering relationship. This other option here, allow forwarded traffic, means that I'm allowing traffic that does not originate in a peered VNet to flow across this peering relationship. So that's not relevant in this demo, so we'll move on to the next one here. This one is allow a gateway transit. So as I mentioned, it's possible to share a VPN gateway. So if this VNet had a VPN gateway and I wanted peered VNets to share it, I could select this box. And lastly, if this virtual network did not have a VPN gateway, but another one did that I was peered with, I could choose this box to use a remote virtual network gateway. I'm not going to select any of these for the purposes of my demo, but I wanted to just tell you what they were briefly. So I'll click OK, and we're basically establishing one side of this peering relationship right now. So while that's going, I'm going to go ahead and set up the other side of the peering relationship. By the way, you can see it just popped up here. Notice the peering status is initiated. It's not connected yet. So let's go to the IT VNet, and again click on peerings. I'll click add. Okay, this time I want to make sure I'm choosing the HR subscription. I'll choose the virtual network of HR VNet, and I'll click OK. And just a second here, we should see this complete, and we should see our peering status come up here. Okay, there we go. So ITDHR is connected now, and if we look at the peering configuration on HR, I think we'll see that it's connected as well. Right. Okay. So we've just established peering between these two VNets, and I think you've seen that it's quite easy to do, not too complicated at all. So now that we know that peering is set up properly, let's do a couple of tests. The first thing that I'll do is back on my Linux VM, I'm going to try this test once more. So this is the same session here, and I'm just going to again try to ping that private IP address of the IT VNet or IT Linux virtual machine. So now you can see that I'm getting responses. And the key thing I want you to notice about the responses, I've just canceled it, is notice the very small response time here. You know, many times it's less than half a millisecond response time. So this is what we would expect in a single virtual network between two virtual machines. But this is again traversing that peering relationship or connection to another virtual network. So very low response times, really good performance on this ping. Now I wanted to show you one more demo here. So I've opened up an RDP session to my DNS server. Again, just to show you that once more, back on my diagram, basically I've RDP'd into this DNS server right here. And I'm going to open up my browser and connect to the load balanced IP of this website. So I think I'll start by resolving the name intranet just to show you that it is a private address. Okay, so that ping is not going to return, but notice that the IP address is a private address. All right, so let's use this name. Okay, so you can see that I am connecting successfully to the website here. And I'll refresh this a few times, and I want you to watch the server name part here. Right now we're on HR Web VM1. And now I've refreshed a couple times, and we've gone to HR Web VM1, and you've seen HR Web VM0 as well. Like that one. Okay, so you can see that we're connected to that load balancer, and the website is functional, again, all across that private peering connection. So that concludes the things I wanted to demo for you. So I'll just go back to my content now. And really I want to summarize kind of what we've covered, some of the high points of what we've covered. The first is that VNet peering, the key benefits really are reducing cost and complexity in your infrastructure, especially if you have a larger infrastructure where you have more than one subscription provisioned or more than one virtual network provisioned. So you notice that it was very easy to set up, not very difficult to do that at all. Also, there's no gateways required. So this is a lower cost option. It is a more performant option as well, since that traffic traverses the Azure backbone. The networks appear as one for connectivity. However, they are still separate VNets, so we can manage them separately. And it enables us to share common infrastructure components. Again, lowering costs, lowering complexity in our environment. So that concludes the content that I wanted to cover for you, and I wanted to ask if there were any questions. Please, if there are, respond in the question section of GoToWebinar. Just click the button to raise your hand and type in your question, and I'll respond to that question. Any questions at all? Okay, I see there's a question here. Does the VNet peering use the private backbone of Azure, which is unbilled? Okay, great question. I think what you're asking there is because the traffic is traversing the private backbone of Azure, is the traffic billed? So there is pricing that is associated, or a cost, with VNet peering. The Microsoft website, the pricing page for VNet peering, gives that cost at 1 penny US per gigabyte of data transferred out of a virtual network, and also 1 penny US of 1 gigabyte of data transferring into a virtual network. So I'd encourage you to go to, just in your favorite browser, just open a search to Azure VNet peering pricing, and you'll find probably in one of the first few links the pricing page that'll give you the details on that. So there is a price for peering. Good question. I see another question here has popped up. Is the traffic encrypted in motion? Another good question. So it's important to know that traffic that's traversing the peering relationship is not encrypted. In fact, there is no option, no checkbox, if you will, to encrypt that traffic. So if you want to encrypt the traffic between two virtual networks, so you want them connected, but you want the traffic encrypted, you'll need to use VPN gateways to set up that connection. Okay, here's another question here. Peering works at intra-region and not inter-region yet. Am I understanding this correctly? Yes, that is a correct understanding. Today we can set up peering for virtual networks in the same Azure region only. Now I have heard that it is on the roadmap for peering relationships to be able to be set up between VNets in different regions. But don't hold me to that. I can tell you today that yes, the only way it works is with or between virtual networks in the same region, not in different regions yet. Any other questions? Okay, I don't see any other questions popping up, so we're going to go ahead and wrap up the webinar. So just another quick point about our company, Opsgility. So we do offer online training And there's up to 60 different self-paced courses that you can take there. And it's covering many different topics, predominantly Azure, but also Office 365 and Dynamics. I do want to point out that you can use our service for 30 days free if you use the Try Opsgility code whenever you sign up. And do note the email address at the bottom of this slide, info@opsgility.com. If you do have questions about this content I've covered that pop into your mind after the webinar is concluded, just send an email to info@opsgility.com, and we'll make sure to get those answered for you. This is just a quick look at some of the instructor-led courses that are available with Opsgility today. Definitely will happily come to your organization and provide training on these topics. And the last thing I wanted to say is thank you. Thanks for attending the webinar today. I know each person on this call is busy and has a day job, so thank you very much for attending the webinar. I hope it was beneficial. Again, my name is Steve Ross, and it's been my pleasure to be with you over this 30 or 40 minutes, and I wish you the best. Thank you.